Welcome to the second video for section 1.3 on solving equations with both sides. In this video, I'm actually not going to show you any new math whatsoever. And if you look at the three problems here, just take a look at them. You see that basically they're structured the same way. You'll see that all three of them have parentheses on the left side. All three of them you're going to be distributing a 2. And you also have a variable on the right side as well that you're going to have to deal with. So the math isn't going to be any different than what you've been doing already, but there are going to be some different situations that I want you to look at. So what I want you to do right now is pause the video and do all three problems separately and see what happens, and then resume the video. So in all three problems, we want to start by distributing the 2 because the parentheses seal terms off, and we want everything to be out of parentheses so that way we can deal with them, we can combine them, we can eliminate things. So we're going to distribute the 2 by multiplication, so this now becomes a 2x. The 2 times the minus 3 becomes a minus 6, and for now there's nothing to do on the right side. So there you go. Now, next part, we've got x's on both sides, so we want to eliminate them on one side. We want to eliminate the side where the coefficient is smallest. You can see that on the left side we're working with a positive 2, and on the right side we're dealing with an invisible positive 1. So since that's the smaller one, that's the one we're going to get rid of, and we're going to get rid of that one by subtracting it. So we're going to do minus x to get rid of that, and then whatever we do on one side, do to the other. So again, minus x equals minus x. And so when we work that out, we're going to end up with just 2x minus the invisible 1x is just 1x. We still have that minus 6, so we're going to bring it down. On the right side, we have a 6, but we don't have the x anymore. So we have x minus 6 equals 6. Next step, and this is actually the last step, we're going to undo the subtraction by adding. So we have plus 6 equals plus 6, and that's going to finish with x equals 12. And so we're going to take that and plug it back in to both sides to just make sure it works. So on the left side we're going to have 2 parentheses 12 minus 3. That equals 2 times 9, which equals 18. And if we take it to the right side, we have a 6 plus 12, and that also equals 18. So here we go, x equals 12. So now we've got a different problem, but the math is going to be the same. And again, the problem isn't that much different from what the first one was. So step 1, just like before, we're going to distribute that, and so we get a 2x, we get a plus 6 equals a 6 plus 2x. Those look pretty familiar. In fact, those look almost the same. And if you're a master of the commutative property, you'll know that those are the same. If you forgot the commutative property, we can go ahead and do the next step, and then we're going to subtract the smaller one, but they are the same. And so we end up with 6 equals 6. So the x is gone. So what does that mean? Well, it means that no matter what x is, the two sides are going to be the same, because you end up with 6 equals 6. So try a few numbers and make them easy. So try x equals 1, try x equals 2, maybe x equals 0. That's pretty easy. You could even do x equals 10, x equals 1,000,000, whatever you want to do. X equals a half. And you'll see that no matter what you plug in, they always work. So when this happens, right, when you look at it, and no matter what you put in, this will give you the same answer as that does. This is something that we call an identity, because it means that really both sides are identical, which you kind of saw already back here, again using commutative property. And so when it's an identity like that, we say that the solution is all real numbers. And yes, there are imaginary numbers, and you'll learn about them in Algebra 2. but all real numbers. So we could even plug in pi and it would work. So anything you want, and that's called an identity. And so for your answer, you want to write it as all real numbers, and spelling will count. So let's take a look at the last problem. Again, no tricks to it. Math's the same. Start by distributing. Oops, there we go. So we get 2x plus 8 equals 6 plus 2x. Kind of looks like what happened before, except last time, remember that this was a 6, and so we had 2x plus 6 equals 6 plus 2x. This time it's 2x plus 8 equals basically 2x plus 6. So what number could x be where that would work? Well, if you're not seeing any, let's try a little bit more math. Let's take it to the next step. So we'll get rid of 2x, and whatever we do left side, do the right side. And so look what we have now. We have 8 equals 6. We've got a problem here because 8 doesn't equal 6, right? 8 does not equal 6. Therefore, what number could x be that would make this true? And the answer is none. No matter what number you plug in for x, and you could do 0, you can do 1, you can do -1, you can do pi, 1/2, 8 million, whatever you'd like to try. It's not going to work. There's no way, there's no number you can put in here and here, and remember that if it's the same variable, it has to be the same number. There's no number that you can come up with that's going to make this work. And if you don't believe me, go ahead, try it. And resume the video when you're done. Because it's not going to work. 8 does not equal 6. So this kind of problem is what's called no solution, because there is no number you can put in to make it work. And in math we actually do have a symbol that we use for no solution, which is a 0 with a line through it. It's a diagonal, and it should start in the upper right and go down to the lower left. And that's it. So if you look back at all three problems, you'll see that they all look the same, and we did all the same math to work them out, but we got different answers. And so, each time the answers mean something. In problem 1, there was a number that x could be to make it work. In problem 2, there could be any number that would make it work. And in this last problem, there was no number that would make it work. So go to Edmodo, do the part 2 worksheet for section 1.3, and again, as you do them, there will be some problems that have one solution, some will have no solutions, some will have the infinitely many solutions. None of these problems will have 2 solutions. You're going to get that later on.